All right, so today we're going to talk about variables. And to do that, we're going to use a new online IDE, and it's called JDoodle. And JDoodle is a lot like BlueJ, except it runs through your browser, okay? So the easiest way to get there is to just Google JDoodle, and then you'll want to select the option Online Java Compiler IDE. Now, there's some stuff in there. You just want to kind of get rid of all of it. Not all of it. Just we'll keep everything. We'll get rid of that. We'll keep this stuff. So what's going on here in this first line of code is you've got a variable. Now, everyone in here has taken Algebra 1. So everybody in here knows what a variable is. It's just something, it's an unknown quantity that can take on any valuable. Valuable? How about any value? Now, what's going on here is actually two things. We're declaring the variable, which is like initializing it, and we're assigning it a value. So we're declaring the variable x, and we're saying that it has the value of 10. So there's two things that are going on there. Now, there's a bunch of different kinds of variables. The first one we're going to talk about here is int, and int is short for integer. You might remember from math that integers are just whole numbers, 0, 1, 2, 3, 4. Also goes the other way, -1, -2, -3, -4, whole numbers. And that's one kind of variable that can exist within Java. Now, that's not the only kind. There's lots of kinds of variables. Another kind you might deal with is ones that are not whole numbers, something with a decimal. And when that happens, you might use a double. Double, and let's call this one y, can take on any value like, 37.2. You can just take on a decimal, right? And it's a pretty common one you'll want to use if you've got a decimal, just anything that's not a whole number. There's different ways to do that. We'll talk about doubles and floats in a second here, but the other major one that we'll talk about are strings. And we talked about strings last class when we were printing out a whole bunch of strings to make a pretty picture. Well, you can declare a string variable as well. I'll just call this one my string. And the way you declare it is by putting a couple of quotes right there and typing in whatever you want. And, and this is how you declare different kinds of variables. So today, and let me just make this a little bit bigger for you so you can see it a little bit better. Today, we'll be talking about, I think, 9 different types of variables. And the 3 that you'll see a lot are integers, doubles, and strings. What are some other kinds? Well, before we get to that, let's talk about identifiers first. Right now, my variables are bad. They're not very good. Actually, 2 of them are bad. 1 of them is good. Usually when we're making variables, we want to use an identifier. Think of an identifier as like a name to mean something. So right now, it just says x and y. You kind of want to name these variables to represent what's going to go into them. And the reason that you want to do that is because maybe you're going to use this variable for something. You're going to use it for a formula. So think about, you want to calculate the area of a circle. So maybe instead of calling it x, you want to call it radius, because you're going to store that radius so the computer has it, and then you can use that radius to do some sort of calculation on it. All right, so try to use names that are meaningful. You can't use every kind of name. Some words are already taken. For instance, I tried to do a variable called static. Notice how the variables that I declared previously are in black. Static is the same color as int. That's because it's called a keyword. And keywords are words that are reserved in Java to mean something else. Okay, so like int has a meaning to Java. Double has a meaning to Java. String has a meaning for Java. So does static. Now, you don't need to know all of them. What you need to know is that when you declare a variable, just make sure it's in black to make sure you're not using a keyword. Some other instances of keywords are return, void, long, break, continue. There's lots of them. Just make sure your variable's in black and you're fine. You're not using a keyword. So these are called primitive types. Int, double string, they're called primitive types. And a primitive variable stores a value of the type specified. The type states how much and what kind of data the variable can store. Now, some of you maybe in another class learned Python. And in Python, you don't have to declare what the variable is. You could just say x equals 10. But Java is what's called a strong typed language, meaning that when you declare the variable, you have to say what's going to go into the variable. So you have to say what's the name, what's going inside. Is it an integer going in there? Is a string going in there? Is something else? You've got to do that every time you declare a variable in Java. Now, you don't have to do that in every language, but in Java you do. And now when you declare the variable, it's going into memory, meaning the computer's going to remember it. It's going to store it somewhere in its memory, its RAM. And if I was to ask you, how much memory does your phone have? What would you say?
8.
What's the unit?
Gigabytes.
Gigabytes, right? Gig is a lot. It means you have a lot of data in there. Now, when I was growing up, I had a Nintendo, and that was 8-bit software. And a bit just is like, okay, so 8 bits is 1 byte. I think Nintendo's actually 8 bytes. And then the Super Nintendo was 16. And then the N64 was 64. And then it went on from there. And then the PlayStation came out and it was a whole bunch. So 8 bits equals 1 byte. And 16 bits equals 2 bytes. 1 byte is 8 bits. And a bit is just like a little piece of information, like a 1 or a 0, essentially. It doesn't contain much information. So a byte is actually a data type we can store. So I could do byte, and I'll call it my byte. Now, we could set it equal to 99. It can take on any value from negative 128 to positive 128. It might be negative 127. I forget. We'll check it in a second here. But it can only store like smaller numbers. It can't store very much. So it's a small data type. So it's more efficient. It uses less memory, but it also cannot contain a large amount of information. Another one's a long. And longs can contain very, very long integers. So like 19 million. How many zeros? Is that 6 zeros? 1, 2, 3, 4, 5, 6. Yeah, 19 million. So longs can have really long numbers, but it can only be integers. Now, if you want to have a decimal, then you could have a float. And that could be like 19 million, 2, 3, 4, 5, 6.23. But the trick with floats is you're going to have to also put a little f at the end of it to demonstrate that it's a float. So that's a little thing you're going to have to deal with on the lab in a second here. At the very end of a float, you've got to put an f to demonstrate that it's a float at the end of the number. Just a weird thing in Java. If you have a long, we also have a short. And shorts are just like shorter numbers. Like maybe 100. Now we could print all of these and we could look at all of them. So let's just do that for a second. System.out.print line. And let's just look at some of these. At the int. Let's do the short. And let's do the float. Just to make sure I didn't screw these up. So if I ran it, click the execute button here, you can see that it's going to just print out those numbers for me. Pretty simple. Now there's a weird character type that I want to talk about. Do I want to talk about it next? Not yet. Well, 2 weird character types. So the last 2 I want to talk about, how many we talked about here? 1, 2, 3, 4, 5, 6, 7. There's just 2 more that you need to be aware of. And those are Booleans and characters. There's 9 total that you need to be aware of. Boolean's pretty simple. It only take on true or false. It only stores 1 bit. It's like a 0 or a 1. It's either true or it's false. So you have to assign it to equal true or to equal false. That's it. Can't equal anything else. So this is helpful when we're doing logic. Now, a character, just that. It's one character. I'm just going to do the letter A. And now I'm going to print that out. So I want to show you something interesting about characters. Something I think that's interesting. So notice what I've done here. I've got a character that's got an A. Now to declare a character, you got to put it in single quotes. Another weird thing about Java. But you can also set it equal to a number. That number is an ASCII value. ASCII is ASCII, and it's a number between 0 and like 35,000. Think of your keyboard on your phone. When you're texting something, you've got all those weird characters, right? There's like 65,000 of them because it's got other languages. So think about like Japanese and Spanish. You've got, like in Spanish, you got the N with a tilde. That's a character. That's an ASCII character, and it has a number value. Look what happens when I'm going to print this out. So I've got my character 1, which is an A, and my character 2, which is a 65. When I actually run this code, when I execute it, they both print out as A's, even though one of them was a number. Why? Why would it do that? And that's because, let me just present this. And this is something, if you have it in front of you, you might want to write this down. You don't need to memorize every ASCII value, but there's 3 that I want you to know. Capital A is associated with 65. Lowercase a is associated with 97, and 0 is associated with 48. If you remember that, you can get the other ones. Because if capital A is 65, guess what capital B is? 66. Guess what capital C is? 67. So you can figure out what the other, if you just remember A is 65, you're going to remember the rest. Lowercase a is 97. Guess what lowercase b is? 98. So you can use your logic to figure out what the other ones are if you remember capital A is 65, lowercase a is 97, and 0 is 48. So I would just, maybe commit these 3 to memory, and then you can get the rest. And then give me a random number. More random, higher.
235.
I heard 50. What did you say? 5,400? Is that what I heard? 15,500. Let's just see what 15,500 is, because now I'm curious. I want to know what it is. What's 15,500? So this, I'm hoping it's nothing bad. Oh, I knew it. So you can have some fun checking on this. I think it goes up to 35,000. I'll show you the chart in a second here. So you can find any character you can think of. There's an ASCII value. So if you just do something like Google an ASCII chart, that's ASCII, you can get the list of all 35,000 of them, okay? The last thing I want to show you today, and then I'll be done. This chart. This is the last thing I want to talk about. It's the storage. So the minimum and the maximum. So a byte is only 8 bits. So it can only take numbers from negative 128 to positive 127. I think I said negative 127. I was wrong. I'm sorry. A short can only take numbers between negative 32,768 to positive 32,767. Integers can be huge. They can be from negative 2 billion to positive 2 billion. Long and float are really big numbers. Also, float and double are really big numbers as well. So if you're dealing with really big numbers, you're probably going to want to use a float or a double. All right. Double's bigger. You can see it's 64 instead of 32. So if you just want to be sure that you've got the right data type, you could just use a double and not use a float. Because if you use a float, then you got to put the little f at the end of the number. A character, what did I say, 35,000? I lied. There's actually 65,000 characters that in the ASCII chart. So have fun with it. See what the 64,000th one is. Yes, sir.
So what's the practicality in writing down the entire character command and you're only printing one letter?
What's the practicality of writing the entire? Okay, rephrase that question for me.
So for like using the character command, it's like character then name equals whatever letter or number.
Yeah.
What's the practicality of doing that if you can just print out those letters just as fast?
So what if it's something that's not on your keyboard, like a character that you want that's not on your keyboard?
Like a Chinese character.
Like a Chinese character, right? Like maybe you do have a Chinese keyboard that you've got attached, but maybe you don't, and you just need like one character. Like this happened to me in math a lot of times. Like in math, I'm looking for like a specific character, like the infinity sign. There's an ASCII value for that. And so most of the time you're right, it's not practical, like just type it. But if it's a specific character, you can cheat and get the ASCII value for that. That's a very good question. Last thing I want to show you is if you ever want to know the minimum and the maximum value, there's a command for that. If you just do byte.min value or byte.max value and print it out, it'll tell you what the minimum and maximum values are. So that's a nice little way to cheat. So the question is always, which one's bigger, float or double? So if you did like float.max value and double.max value, you can see that float's a really big number. That's a 3 followed by like all these decimals and then like a bunch of zeros. But that's 10 to the power of 38. This is 10 to the power of 308. So a double's going to always be able to hold bigger values than floats. So when in doubt, just use a double. But float would probably get it done too. Okay, I think that's all I wanted to talk about today. Just check. So I'm going to start. Okay, goodbye if you're watching. Thanks. Sorry.